3, 2, 1.
Safety experts are sounding the alarm, calling for urgent testing of tap water around Australia to identify how much of a cancer-causing toxin it contains. It follows a declaration in the United States that chemicals known as PFOS and PFOA have no safe levels of exposure.
We know those chemicals have been found in Australian water before, but in many cases it's been over a decade since comprehensive testing was done.
Yeah, because of this environmental issue happened in Australia, so it might be also happen in Singapore. So we are coming from group 5, modern analytical modules. Me, Kustomo,
Sean, Ibrahim, Mustafa.
We decided to propose our group projects about analysis of organic pollutants in the water environment using Liquid Chromatography-Mass Spectrometry or LCMS. One of organic pollutant that we will concern in this project is PFOS or Perfluoro Octane Sulfonicacid. In more detail, what is PFOS? It is one of the persistent organic pollutants which is related to the perfluorinated alkylated substance or PFAS. They are also called perfluorochemicals or PFCs. This artificial chemical is commonly used in a wide range of industrial processes and is found in many consumer products like stain-resistant fabrics, firefighting foams, food packaging, and also as a surfactant in industrial process. Perfluoroalkyl substance or PFAS can be found in many consumer products like the pesticide or herbicide, food packagings, commercial household product, and then also the most important things in this study is in the waters. How do they release into waters? So PFOS release into the natural water sources via industrial or domestic wastewater disposal. Also, the use of commercial product with this chemical release these chemicals into the environments. Therefore, they are found in soil, air, surface water, groundwaters, and also drinking waters. Consumption of drinking water with contaminated PFOS is proven hazardous for human health. Therefore, the organization like the United States Environmental Protection Agency recommend to remove these chemicals from the drinking water since 2021. Because study from the EPA show that in certain level of PFOS in drinking waters or in the waters can cause several negative effects to the human health, like during pregnancy or breastfed infants, like low births, accelerated puberty, cancers, liver effects, immune effects, thyroid effect, and many more.
So how do we analyze PFOS? One of the most effective methods is LCMS. And why do we use LCMS?
Here are some reasons. The first reason is high sensitivity. LCMS offers exceptional sensitivity, allowing us to detect low concentrations of PFOS. And the second reason is specificity. It provides highly specific results, reducing the chances of false positive. And the third reason is versatility. This method can analyze a wide range of compounds and is adaptable to different sample types.
Okay guys, I will tell you about the step of analysis of PFOS in the water sample by LCMS. First,
we collect the sample of waters from any kind of tap waters around campus, like in front of the lectures, theaters, mosques, public space, hostels, and many more using the centrifuge tube. And then we bring it into the laboratory to be analyzed.
Sample preparation. The first step in the analysis is sample preparation. This often involves the following steps. Collection. Samples can be collected from various matrices such as water, soil, or pollutant. Filtration. For water samples, it's critical to filter the sample using a 0.45 micrometer filter to remove practice. Extraction. Given the low concentration of PFOS in many samples, solid phase extraction (SPA) is commonly employed. This method concentrates the PFOS, making it easier to detect. Chromatographic condition. Next, we move on the liquid chromatography phase. Column selection. A reverse phase column, typically C18, is ideal for separating PFOS. Mobile phase. The mobile phase usually consists of a mixture of water and an organic solvent, such as methanol or acetonitrile. Adding an acid like ammonium acetate can enhance ionization. Flow rate. A typical flow rate is set between 0.5 and 1 milliliter per minute. Mass spectrometer setting. Once the sample is separated, it is analyzed using a mass spectrometer. Ionization source. We use electrospray ionization (ESI) in negative mode, since PFOS is a strong acid. Detection setting. The mass spectrometer is optimized to monitor specific ion transitions of PFOS. Data acquisition. During data acquisition, we employ targeted analysis, often using selected reaction monitoring (SRM) for enhanced sensitivity. This method allows us to precisely measure the concentration of PFOS in our samples. Data analysis. After obtaining the data, we analyze the chromatogram quantification. We compare the peak area of our sample against the calibration curve created from known concentration of PFOS. Quality control. It's essential to include blank and standards to validate our result and ensure accuracy. Method validation. Finally, we validate the method by assessing parameters like accuracy, precision, limit of detection, and the limit of quantification. This step ensures that our method is reliable for routine monitoring of PFOS.
In summary, analyzing PFOS using LC-MS contains careful sample preparation, optimized chromatographic and mass spectrometry techniques, and through data analysis. And finally, we can say that LC-MS is one of the modern analytical techniques that can be used not only for analyzing PFOS but also for other organic pollutants.
That's all of our presentation today. Thank you for listening, and bye-bye.